Hello, AP Stat students. Previously, we talked about confidence intervals, and that is one of the two most common types of statistical inference. The other one, and that you want to use it when your goal is to estimate a population parameter. The other type of inference is called a significance test, and it has a different goal. Our goal is to assess the evidence provided by data about some claim concerning a parameter. Here is a sample situation that introduces a claim. A basketball player claims to make 80% of the free throws he attempts. You have seen him play basketball before and you don't believe him. So you ask him to shoot some free throws. Suppose he shoots 50 free throws and makes 32 of them. Is his claim true, but he just had a bad streak, or is his claim false? Okay, we will answer all of these prompts and come up with a decision about his claim being true. First thing, what is the sample proportion? So what is p hat? So he makes 32 out of 50 free throws. So p hat is going to be 0.64. So 0.64 or 64% is the success rate. Part B, what can we conclude about the player's claim based on sample data? When you're an 80% free throw shooter, you don't always make 80% of your free throws. Instead, we average all performances of shooting free throws to get the 80%. So how do we determine the likelihood, the probability that he had a bad streak? We can perform a simulation to find out. We used Fathom software. It's one of the softwares, like there's also Minitab and Jump, to simulate 400 sets of 50 shots, assuming that the player really is an 80% free throw shooter. The dot plot of the results is below. Each dot is the proportion of shots made for each group of 50 attempts. So if we look at the dot plot, slow, okay. 0.8 would be like 40 out of 50 free throws made. So all of those would be 0.80. So each of the dot would represent a set of 50 attempts. How many of the 400 sets of shots were at our sample proportion, which is 0.64 or lower? And if you look, they're circled here. Only 0.64 has an arrow by it. So if you look over here, these three, in 400 sets of 50 shots, there were only 3 times when our shooter made as few as the observed statistic. So that's 3 over 400, which is 0.0075, so not even 1%. You can say how strong the evidence against the player's claim is by giving the probability. That he would make as few as 32 out of 50 free throws if he really makes 80% in the long run. Part D. What is the probability that he made only 32 shots out of 50 tries just by chance or bad streak? Based on the simulation, our estimate of this probability is 0.0075. The observed statistic p hat equals 0.64 is so unlikely that it gives convincing evidence that the player's claim is not true. Be sure that you understand why this evidence is convincing. There are 2 possible explanations of the fact that our virtual player made only 0.64 of his free throws. 1, the player's claim is correct, so the true proportion is 0.8, and by bad luck, a very unlikely outcome occurred. Or 2, the population proportion is actually less than 0.8, so the sample result is not an unlikely outcome. And 2 is probably more plausible to believe. All right. Significance tests. A significance test is a formal procedure for comparing observed data with a claim, which is a hypothesis, whose truth we want to assess. We express the results of a significance test in terms of a probability that measures how well the data and the claim agree. Significance tests deal with claims about a population. They ask if sample data give good evidence against a claim. If we took many random samples and the claim were true, we would get a result like this P% of the time. This value right here is called the probability value, the P value. So the basic idea is an outcome that would rarely happen if a claim were true is good evidence that the claim is not true. So if it's very rare that would happen by chance, then our claim is probably not true. Right. Okay, in the next little portion, we're going to learn how to state hypotheses. There are two kinds of hypotheses. There's what is known as the null hypothesis, and that's H sub 0, and it is a statement of no difference. So what the person claims to be true, it will always be in the form H sub 0 with a colon, and then it'll give you either P equals a value or H sub 0 colon. If you're dealing with means, then mu equals some value. So this is what it would look like. The second hypothesis is known as the alternative hypothesis, and it's H sub A or HA, the claim that we hope or suspect is true. Instead of the null hypothesis. Alternative hypotheses can be one-sided or two-sided. When it's one-sided, the alternative hypothesis will claim that the actual parameter is either less than or greater than the null hypothesis. So I'm going to put either less than or greater than our null hypothesis. It will always be in the form, so one of these four types. And I'll just focus on the proportions because that's what we're concerned in this unit. So I'll just box in those. So it will be HAP is greater than or HAP is less than. And then we have a two-sided alternative hypothesis. It will claim that the actual parameter is not the parameter stated in, and it will look like this. And the thing to remember is all of these numbers right here will be the same values. And I wrote that right here. So note, the number in the null and alternative hypothesis will always be the same. Right. Let's look at a few examples, and we won't do all of them, but I want to do at least the first one and then the bottom one. So we're focusing on our proportions, but I want to do the first one because we're going to use it on another page. Sample. Mike is an avid golfer who would like to improve his play. A friend suggests getting new clubs and lets Mike try out his 7-iron. Based on years of experience, Mike has established that the mean distance that balls travel when hit with his old 7-iron is mu equals 175 yards with a standard deviation, sigma, of 15 yards. He is hoping that his new club will make his shots with the 7-iron more consistent, so less of a spread. So he goes to the driving range and hits 50 shots with the new 7-iron. State the appropriate null hypothesis. Should be hypothesis, not hypotheses, but it would be H sub 0 colon, and we're not using mean this time because he's hoping that he will have less spread. So you're actually using standard deviation, rarely ever used, but we're doing it for this example. So our null hypothesis that there's no difference is the standard deviation is 15 yards. And our alternative hypothesis, he is hoping that it's going to be less spread, so standard deviation less than 15 yards. But that's not all you do. When you list your null and, I was supposed to put the alternative on this spot. So when you list your null and alternative hypothesis, you must state what your parameter actually means. So this is the actual or true standard deviation of the distance traveled. You will get points taken off on a test if you don't identify your parameter in context. With his 7-iron, so be really careful and make sure you identify your parameter. Okay, and then we will skip the next two and we will go to the last one here on this page. Heading into the election, Jack needs 50% of the vote or higher to win the election. Jack is pretty confident that he will win the election. Is his confidence warranted? So the null hypothesis, this time the H sub 0 portion is given, that the null hypothesis, so the statement of no difference, P is equal to 0.5, and Jack wants 50% or always higher than that value. So, well, in this case, 50% or higher. So our alternative hypothesis, HA, will be P greater than 0.50, where P is the actual proportion, the true proportion, that Jack earns in the election. Now, just some information about hypotheses. The alternative hypothesis should express the hopes or suspicions we have before we see the data. It is considered cheating if you look at the data first and then frame the hypotheses to fit what the data show. Hypotheses always refer to a population, not to a sample. And you saw that in the previous example. Well, especially with the basketball one, because our proportion was 0.80. If unsure, so if you're unsure whether you're supposed to use greater than or less than, then use a two-sided alternative hypothesis. Okay. Right. Now, interpreting p-values, which are going to be basically, it gives us the conclusion, and you'll see more about p-values when we do a full significance test. To determine what p-value is considered, the probability that measures the strength of evidence against a null hypothesis is called a p-value. The smaller the p-value, the stronger the evidence against the null hypothesis provided by the data. What's considered small enough? I will tell you here in a second. The p-value is the conditional probability. So it's the probability of the sample data given, it's always based on the null hypothesis is true. So given that the null hypothesis is true. To determine what p-value is considered small, so if it's small enough, you would reject the null hypothesis. In favor of the alternative. Or if it's large, then you fail to reject. The null hypothesis. It's H sub 0. We compare it to what is known as a significance level. And the significance level is represented by the Greek letter alpha. So this is alpha. Significance level requires evidence against the null hypothesis to be so strong that it would happen less than alpha % of the time by chance when the null hypothesis is true. Oops. Okay. When our p-value is less than our chosen alpha, we say that the result is statistically significant. And statistically significant just means unlikely to happen by chance. So significant doesn't mean important, it means not likely to happen by chance. If you are going to draw a conclusion based on statistical significance, the significance should be determined before the data are produced. Significance level should range from 0.1 to 0.001. Courts will accept 0.05 or lower. When in doubt, or if not explicitly stated in a problem, use 0.05. So this is the standard alpha that you would use if not given one. All right. The final step in performing a significance test is to draw a conclusion about the competing claims you were testing. We will make one of two conclusions. This part is really important right here. Based on the strength of the evidence. So one of the conclusions you can make is reject the null hypothesis. And you do that when the p-value is less than alpha. The other one is fail to reject the null hypothesis. And that's when the p-value is not less than alpha. So the p-value is greater than alpha. Oops. Put that over here. But just because you fail to reject the null hypothesis does not guarantee that the null hypothesis is true. It just says that there is not enough evidence to reject, right? You never, ever accept the null hypothesis or you will lose credit. So your two options are you reject the null or you fail to reject the null. In the free throw shooter example, the estimated p-value of 0.0075 is strong enough against the null hypothesis because it is less than that 0.05. So it's strong evidence against the null hypothesis. And the null hypothesis was H sub 0, P equals 0.80. For that reason, we would reject the null hypothesis in favor of the alternative hypothesis, where the proportion was less than 0.80. It appears that the virtual player makes fewer than 80% of his free throws. Let's go back to our 7-iron example. When Mike was testing a new 7-iron, these were his hypotheses. So HO sigma equals 15, HO standard deviation less than 15, where, so notice here the parameter was identified when the hypotheses were given based on 50 shots. So here's the sample data right here. Based on 50 shots with his new 7-iron, the standard deviation, so this is sample, standard deviation is 10.9 yards. A significance test was done and the p-value was given. So here's the p-value. Interpret the p-value in this context. And I am pretty positive you will get a quiz question or test question where you have to interpret what a p-value actually means in context. So in this case, I remember a p-value is based on the fact that the null hypothesis is true. So if, and the null hypothesis is 15 yards. So if the true standard deviation is 15 yards, the probability of getting a sample, or in this case, getting a 10.9 standard deviation from our sample would be 0.002. Our significance level is 0.01. What should our conclusion be? So let's compare our probability, our p-value, to this 0.01. And 0.002 is less than 0.01. Therefore, you must reject the null hypothesis. And then if you reject the null hypothesis, what is your conclusion? And this is your conclusion. We have convincing evidence that the standard deviation with the new 7-iron is less than 15 yards. So we reject the null hypothesis in favor of the alternative hypothesis. Now we will do our last example. For his second semester project in AP Statistics, Zenon decided to investigate if students at his school prefer name brand potato chips to generic potato chips. He randomly selected 50 students and had each student try both types of chips in random order. Overall, 34 of the 50 students preferred the name brand chips. Zenon performed a significance test using the following hypotheses. So the null hypothesis is the proportion p equals 0.5, and the alternative proportion is greater than 0.5, where p, so again, this was identified here, where p is the true proportion of students at his school that prefer name brand chips. The resulting p-value from his test was 0.0055. What conclusion would you make at each of the following significant levels? State the conclusion in context. So when he did his test, if he had used if the alpha was 0.01, what could you conclude about his p-value? So we have 0.0055, compare it to alpha, and 0.0055 is definitely less than. So we are going to reject the null hypothesis. And now the tricky part, or the most challenging part, is to write it appropriately, write your conclusion in favor of the alternative hypothesis. So we have convincing evidence that the proportion of students at Xenon School that prefer name brand chips is greater than 50%. Right. For the second one, what if the alpha was 0.001? That was our significance level. So comparing the p-value 0.0055 to 0.0001. And sometimes it helps to line the numbers up and then look at your digit. Look at this one compared to that. So therefore, the p-value is greater than. So here, it's not less than alpha. Therefore, you fail to reject a null hypothesis. And your conclusion would be, we do not have convincing evidence and all the rest of the stuff I'm not going to rewrite, because that the proportion of students at Xenon School that prefer name brand chips is greater than 50%. And so that really covers how to write hypotheses and how to interpret p-values. Next time, we will actually do a significance test for population proportions. Have a great day, stat students.